we are going to solve rational equations. And these take a little bit more work than polynomial equations because we have that denominator to worry about. So the big thing to keep in mind here is something called an extraneous solution. An extraneous solution is a solution that we find that isn't valid in the original equation. And we'll show an example of this as we go, but let's just start by solving first. So suppose we start with 1 over x minus 12 over 5x plus 10 equals 1 over 5. The first thing we're going to do is we're going to find our lowest common denominator, and that comes by factoring. So in our denominators, we've got a 5 and 2 of them. We've got an x by himself, and we have an x plus 2 by himself. Now, because of the extraneous solutions, I always stop at this point and say my lowest common denominator cannot equal 0. So that says x can't be 0, and x can't be negative 2, because if I plug in a 0, I get 0, and if I plug in a negative 2, I get 0. But the 5 doesn't affect it, because it's just a 5. 5 is never equal to 0, it never contributes. So let's multiply both sides by 5x times x plus 2 over 1, and 5x times x plus 2 over 1. That means we get to write each one by that. So 1 over x minus 5x x plus 2 over 1 times 12 over 5 times x plus 2 equals 1 over 5 times 5x times x plus 2 over 1. So when we divide out what's in common, in our first term, the x's go away. In the second term, the 5 and the x plus 2 goes away. And in the third term, the 5 goes away. So this gives us 5x plus 10 minus 12x equals x times x plus 2, or x squared plus 2x. Combine like terms. Subtract everything to the other side, so we'll subtract 10 and add 7x, gives us 0 equals x squared plus 9x minus 10. Factors of minus 10 that add up to positive 9 are minus 1 and plus 10. So x is 1 and x is minus 10. Since neither of these are disallowed by our lowest common denominator, they can both be our answers. So we get minus 10 and 1, and if we wanted to check our answer to be sure, we could, and we'd see that they both work. Now, I want to show another example of x over x minus 2 minus 2 over x plus 2 equals 4x over x squared minus 4. And so we start by factoring. This gives us x plus 2, x minus 2. So our LCD is x plus 2 times x minus 2. When we set that not equal to 0, this means x can't be negative 2 and x can't be 2. Well, when we multiply everything by, let's multiply everything by x plus 2, x minus 2 over 1, and x plus 2, x minus 2 over 1. Minus x plus 2, x minus 2 over 1 times 2 over x plus 2 equals 4x over x plus 2, x minus 2 times x plus 2, x minus 2 over 1. Divide out what's in common, and we get x plus 2 times x minus x minus 2 times 2 equals 4x. Well, I'm going to move this 2 to the front just to make it a little bit easier to distribute. And that gives me x squared plus 2x minus 2x plus 4 equals 4x. X squared plus 4 equals 4x. Subtract the 4x. X squared minus 4x plus 4 equals 0. This is a perfect square trinomial. It factors as x minus 2 squared equals 0, so this gives me the equation x equals 2. However, note that x can't be 2, so I have to rule this answer out, and since all of my answers went away, this is a no solution problem. So always, always, always check your answers against your LCD to make sure that you don't ever divide by 0.